Okay, question 3, we're told here the sum of the first two terms of a geometric series is 6.4. So in other words, t1 plus t2 is 6.4. Okay, remember t1 is just a, isn't it? Yeah, first term. t2 then is you timesing a by r, so ar. Okay, or you can put 2 in there. You end up with ar, and that equals to 6.4. Okay, and what I would do with this now, when I've got this here, I'd possibly think about factorising out the a to begin with here. Okay, so if I factorise out an a, I've got a bracket, well a times 1 gives me a, and then a times r gives me ar, equals 6.4. Okay, so I might just leave that for a minute, and I'll see what other information I've got, and I'll come back to it then. So then it says the sum to infinity of the series is 10. Okay, so we also know then sum to infinity is 10. That means we've got this here, isn't it? A over 1 minus r equals 10. Okay, and I think the tempting thing here then is just to take the 1 minus r over to the other side. Okay, so a then will be 10 bracket 1 minus r, okay, because you're dividing by it, take it over. And now notice I've got an expression for a, right? So if I call that equation 2 and now that equation 1, and if you think about it, because I've got an expression for a in terms of r, I could sub it in, couldn't I? I could sub 2 into 1. Okay, so then I have, well, a becomes 10, 1 minus r, and I got 1 plus r equals 6.4. Okay, now we can be clever here how we then sort of go about simplifying this, expanding brackets and so forth, yeah, to get to an answer. Now what I'd be tempted to do here is, to start with, is divide both sides by 10, okay, or think about taking that 10 over the other side and dividing, okay. But whatever happens, if you divide this side by 10, that 10 will disappear and you just have this double bracket. Of course, divide this by 10, you have 0.64, okay. So then this times this bracket out, and what's really nice is, when you do the first here, you get 1, when you do the outers and inners, you get plus r minus r, they'll cancel each other out, and then you get minus r squared is 0.64. Okay, so they cancel each other out. Maybe I'll do 1 and take away 0.64, take that over the other side, take this over this side. So then r squared is 0.36. Okay, so then you've got a square root, but don't forget plus or minus square root. So r will equal to plus or minus 0.6. Okay, but it does say in the question, given that the common ratio is positive. So given r is positive, r will equal to positive 0.6. Okay, and then it says find correct to 3 decimal places. So in B, the sum of the first 11 terms of the series. So remember, for the sum formula, which I've got up here, I need to know n, obviously, so 11 is what n is going to be. I've got r, but I need to find out a. So to find out a, I need to now sub it back in. So we can sub it back into equation 2. So sub r equals 0.6 into 2. So I found out r, and we're taking the positive one. That means a is equal to 10, 1 minus r, 1 minus 0.6. So a will equal to 4. Okay. And then the sum of the first, what did they say, 11 terms. So I've got to use that formula. Okay. Okay, so let me write that formula down again, so we can see that here. Right, so the sum of the first 11 terms is going to be, while a is 4, 0.6 to the power 11, all divided by 1 minus 0.6. So we're going to put that in our calculator, and we want it to 3 decimal places. So I've got, all in one go, our answer to be let's just check this, the power 11, 9.63, no, I've written that down wrong, 9.964 to 3 decimal places. Okay, 9.964.